Hello everyone, I am Dr. Pavitra Singh. Today I will discuss about engineering drawing in this video. So as we have studied about the projection of points, projection of lines in the previous videos. So today we will discuss about the projection of planes. So in the case of projection of points, we have considered a point which is dimensionless, and in the case of line we have taken the segment of different points which is giving you a line, and this line is one dimensional. Again, the segment of different lines will give you a plane, so this will be actually two dimensional. If we are using the segment of different planes, so this will give you a third dimension, so this will be actually solid, means three-dimensional view. So today we will discuss about the projection of planes. So in this problem, it is given that a regular hexagonal lamina of 20 mm side rests on one of its side on the horizontal plane, and it is parallel to the vertical plane, and it is 12 mm away from this vertical plane, and it is in first quadrant. It means we have to draw the projections in the first angle. Okay, so actually this lamina is resting on its one side, and suppose this is one side, 6 dash 5 dash. Also it is away 12 mm from vertical plane. So actually this will be like this. Okay, so this is vertical plane, and this is horizontal plane, and this hexagonal plane is lying on this horizontal plane. Okay, so actually this side, this is 12 mm away from this vertical plane. Okay, and this side is parallel to this vertical plane. That's why this will be projected in the top view. So when we will see this from top, so it will be visible like a line. So actually the complete figure will be seen in the front view, because its one side is resting on the horizontal plane, and this plane is 12 mm away from this vertical plane, this distance. Okay, so this will be actually projected like this. So from the top we can see this plane as a line. So now we can see the complete hexagonal shape from the front view. That's why we will draw this hexagonal lamina first. So we will draw one line XY. So actually this XY line is the line of intersection of these two planes, vertical plane and this is horizontal plane. So these two planes are connected with this line, okay, this line. So this is actually the line of intersection of these two planes. So this is actually called reference line XY. So this line is drawn first, and on this line we will draw this line 6 dash 5 dash. This is equal to 20 mm. Now we will construct this hexagonal plane. So actually we need this angle, this angle, this angle, this angle, and this. Okay, so to construct this hexagonal lamina, we need its side and angle. So all sides are equal because it is a regular hexagonal lamina, and all angles will be same. So actually we can calculate this angle 180 degree minus 360 degree by number of sides are 6. Okay, so we can say this will be equal to 120 degree. So this angle will be 120 degree. Okay, so now we will draw this line 1 dash 6 dash at an angle of 120 degree, and this line will be equal to 20 mm. Similarly, this line, this line, this line, this line. So we have constructed this regular hexagonal lamina of side 20 mm. Okay, now we can say this is the front view of this hexagonal lamina. If we are looking this lamina from the top direction, so this line and this line and this line will be visible from the top direction. Okay, and this will be projected 12 mm away from the vertical plane, means below the xy line. So this will be actually point 1 2 3 4, 1 2 3 4. Okay, and point 5 6 means this line, this line, this line will be in the back side. So you can see at this point, point 2 is here and point 6 is here, point 5 and point 3 will be on this point. So this is actually top view of this hexagonal lamina. So this was the solution of this problem. Now we will try to solve another problem. So in this problem you can see a regular hexagonal lamina of 12 mm side has its one edge on the horizontal plane. The surface of the plane is perpendicular to the vertical plane and it is inclined at 40 degree to the horizontal plane. Then we need to draw the projections of this plane. Okay, so in this problem you can see side of this hexagon is 12 mm and its one edge is resting on the horizontal plane. Okay, means this edge is resting on the horizontal plane and the surface of plane is perpendicular to the vertical plane, means this surface is perpendicular to the vertical plane, means this is vertical plane and this is perpendicular. That's why we can see the complete surface from the top direction and we can see only line from the front direction. Okay, so first we will try to draw the top view of this plane, because we can see this complete figure from the top. Okay, so here top view will be below the xy line, so this is actually xy line and this is top view. So side of this plane is 12 mm and this angle is equal to 120 degree. So we will draw line BC which is lying on the horizontal plane. Okay, and now we will draw line CD, DE, EF, FA. So we will get this regular hexagon of side 12 mm. So this is actually front view. So we can see this plane completely from the top. So this is our front view. Now we will draw vertical lines from point A, from point B, C, D, E and F. So these vertical lines are A dash. So these lines are connecting on this xy line at point A dash, B dash, C dash, D dash, E dash, F dash. So point F and B will be on the same point. Point E and F, E and C will be on the same point. So this is actually our front view. Okay, so this is front view and this is top view. Now we will follow the second condition. It is given that this plane is inclined 40 degree with the horizontal plane. That's why we will rotate this front view A dash to D dash. In this figure you can see at an angle of 40 degree. Okay, so this shape is same. So final answer is this one. Okay, so in this figure we have inclined this front view A dash to D dash at an angle of 40 degree. All the sides are same, A dash B dash, B dash C dash, D dash. Okay, so same line is here, only it is inclined at 40 degree. So now we will draw vertical lines from point A dash, horizontal line from point A. So we will get this point A1. Similarly, horizontal line from point B, vertical line from point B dash. So these two lines, vertical line and the horizontal lines, are intersecting on this point. That's why this will be new point B1. Similarly, horizontal line and the vertical line from C dash, so this will be actually C1. And this horizontal line is intersecting this vertical line. So this is from point D and this is from point D dash, so this will be D1. Similarly, we will draw vertical line from point E dash and horizontal line from point E, so this will be actually E1. Now we will draw horizontal line from point F and vertical line from point F dash, so this will be new point F1. So now we are having 6 points A1, B1, C1, D1, E1, F1. So this is actually the top view of this plane, which is inclined 40 degree with the horizontal plane. So this is inclined 40 degree with the horizontal plane. So this is the final answer of this problem. So you need not to draw this figure, because I have drawn this partly step by. So this is your complete answer. Now in the third problem, draw the projections of a perpendicular plane of side 25 mm which is resting on horizontal plane and its one edge is perpendicular to the vertical plane. The plane of the pentagonal is inclined at 45 degree to the horizontal plane, and this again inclined 30 degree with the vertical plane. So the perpendicular drawn from the midpoint of the resting edge. So actually this is the midpoint, this one, midpoint of this line AB, which is resting on so midpoint of the resting edge makes an angle of 30 degrees. So actually this line is divided in two parts, means this is the midpoint. So we will draw this center line. Okay, so now we will try to solve this problem. So first we will solve this problem here to here only. So as per this first condition, we can see this pentagonal prism is parallel to the horizontal plane, and its one side AB is perpendicular to the vertical plane. Okay, so we can see this complete pentagon from the top. Okay, when we will rotate this in the clockwise direction, so this will be the top view. So we can see complete plane in the top view. So we will draw one line which is perpendicular to the xy line, because this is perpendicular to the vertical plane. So we will draw this line first and we will mark point A and B, and this distance is 25 mm. So this length is 25 mm. Okay, now we will draw this line BC. So this angle should be known. So this will be actually 108 degree, because 360 minus 180 minus 360 divided by number of sides, which are 5. Okay, so this will be actually 180 minus 72 degree is equal to 108 degree. So this angle will be 108 degree. So now we will draw this line BC, which is inclined 108 degree with the AB line. Again we will draw this line CD, DE and EA. So we will get this regular pentagon. Okay, so now we will draw vertical lines from point A, from point B, from point C, from point D, from point E. So point A and B will be on the same location, because point A is overlapping point B and point E is overlapping by point C. So this will be the location of point C and E. Okay, so this is actually top view and this is our front view. A dash, B dash, C dash, E dash and D dash. So this is front view. Okay, now we will follow the second condition. The plane of pentagon is inclined at 45 degree to the horizontal plane. So now we will incline this line A dash to D dash at an angle of 45 degree. So all the dimensions will be same, only we need to tilt this line at an angle of 45 degree. So we have redrawn this line at an angle of 45 degree. Okay, now we will draw vertical projections from point A dash, B dash, C dash, D dash, E dash. Okay, so we will draw vertical projections from each and every point and horizontal projections from each and every points. So the intersection of horizontal line and vertical line will give you a new point. So now we will draw one horizontal line from point A, vertical line from point A dash. So we will get this point A1. Again horizontal line from point B, vertical line from point B1. So we will get this point B1. Similarly, horizontal line from point C and vertical line from point C dash. So this will connect this horizontal line at point C1. So this is the new point C1. Again we will draw horizontal line from point D, vertical line from point D dash. So this will be a new point D1. And the intersection of this horizontal line from E and from E dash will give you point E1. So now we are having 5 points A1, B1, C1, D1, E1. So this is our new projected surface. So this is actually top view. So we will connect all these points A1, B1, C1, D1, E1. So we will get this new shape or surface which is inclined 45 degree with the horizontal plane. Again we will try to follow the third condition, which is given that this plane is again inclined 30 degree with the vertical plane. So actually previously this plane was like this, okay, and again it is inclined 45 degree with the horizontal plane, okay. So this is actually 45 degree. Again this is inclined 30 degree with vertical plane. So you can see this surface, okay, in the final projection. So this surface is this one, okay. So now we will reconstruct this shape here at any distance. So we will leave some space and we will reconstruct this plane here, but condition is that, as per the given problem, the perpendicular drawn from the midpoint of the resting edge. So actually this is the resting edge which is perpendicular to the vertical plane, and the midpoint of this line is this. Suppose this is O. So we have drawn this line O D1. So this is center line of this pentagonal plane. So this line OD1 is inclined 30 degree with the vertical plane. So we will draw first this line at the inclination of 30 degree with vertical plane or XY line. So this is actually top view, so this will be below the XY line. So we have drawn this line, and this point O is here, this one. D1 is this, C1 is this, B1 is this, A1 is this, E1 is this. So actually the same plane is inclined at 30 degree with the vertical plane. So we have redrawn this plane at an inclination of 30 degree with the vertical plane. So now we will draw vertical line, vertical projection from point A1, horizontal projection from A dash. So the intersection of this horizontal line and vertical line will give you one point A1 dash. Okay. Similarly, horizontal line from point B dash, vertical line from B1, so you will get this point B1 dash, vertical line from point C1, and horizontal line from point C dash, so this will be point C1. Okay. Now vertical line from point D1, horizontal line from point D dash, so we will get this point D1. Similarly, horizontal line from point E dash, vertical line from point E1, so we will get this point E1 dash. So now we are having 5 points A1 dash, B1 dash, C1 dash, D1 dash and E1 dash. Then we will connect all these points, so we will get this new shape or surface, which is a pentagonal surface, and this surface is inclined 45 degree with the horizontal plane and 30 degree with the vertical plane. So this is our final projection, means this will be actually front view of this plane, which is inclined 45 degree with the horizontal plane and 30 degree with the vertical plane. So this was the solution of this problem. So now we will try to solve one more problem from this projection of planes. So actually a circular lamina of 65 mm diameter rests on the ground such that the surface of the lamina is inclined at 30 degree to the ground, means with the horizontal plane. This is 30 degree inclined. Previously it is like this. Okay, now it is inclined 30 degree. So the diameter through the point on which the lamina is resting on the ground appears to be inclined 45 degree with the horizontal plane. So now we need to draw its projection. So actually, suppose a circle is lying on the horizontal plane. Okay. Now it is inclined 30 degree with the horizontal plane, and its edge is touching this horizontal plane. Okay. So this plane is making 30 degree with the horizontal plane. Okay. Again it is inclined 45 degree with the vertical plane, like this. So this, you can see this surface in the final projection. So this is actually this one. Okay. So first, this is our solution figure. So I have drawn this stepwise. So now I will try to solve this problem here. So first we will draw XY line, means a reference line. So each end in each and every problem we need to draw this XY line. So actually this is the reference line which is connecting the vertical and horizontal plane. Okay, so now as per the given condition, so we will solve this first here to here. Okay, so sorry, here to here only. Okay, then we will consider this condition, then this condition. So now we will draw a circle below the XY line because this lamina is resting on the horizontal plane. So we can see this lamina from top. So this will be actually circular when we will rotate this horizontal plane like this. Okay, so this will be projected in the vertical plane and which is below the XY line. So first we can see this complete surface in the top view. So we will draw top view first. So suppose this is the center of this circle and we have drawn this circle of diameter 65 mm. Okay, now we have selected 8 points on the periphery of this circle. Okay, so this is point 1 2 3 4 5 6 7 8. Okay, so there are 8 points. It may be 16 20 24 as per your choice. So I have selected 8 points. Now I will draw vertical projections towards this XY line. Okay, vertical line from point 2, vertical line from point 3, from 4, from 5, from 6, from 7, from 8. So point 1 will be 1 dash in the front view. Point 2 and 8 will be on this location. So this will be 2 dash 8 dash. Point 7 and 3 will be on this location. So this will be point 3 dash and 7 dash. Point 4 and 6 will be on this location, 6 and 4, and 5 will be projected on this point. So this will be our front view 1 dash to 5 dash. Okay, now we will follow the given condition. It is given that it is inclined 30 degree with the ground or with the horizontal plane. So we will redraw this front view here at an angle of 30 degree. Okay, so all dimensions means length of points will be same. Okay, so now we will draw vertical line from point 1 dash, horizontal line from point 1. So we will get this point 1 1. Similarly, vertical line from point 2 dash, horizontal line from 2. So this will be 2 1. Vertical line from point 3 dash, horizontal line from point 3. So we will get this 3 1. Vertical line from point 4 dash, horizontal line from point 4. So this will be 4 1. Similarly, vertical line from point 5 dash, horizontal line from point 5. So this will be 5 1. Vertical line from point 6 dash, this line. Okay, horizontal line from point 6. So we will get this point 6 1. Horizontal line from 7, vertical line from 7 dash. So this will be 7 1. Similarly, horizontal line from point 8 and vertical line from point 8 dash. So this will be actually 0.81. Okay, so now we are having 8 points 1 1 2 1 3 1 4 1 5 1 6 1 7 1. Now we will connect all these points, then we will get this surface. So this surface is actually inclined 30 degree with the horizontal plane. So you can see this length 3 to 7 is same in this figure and in this figure, but this distance 1 to 5, the distance 1 to 5 is decreased because of this inclination. Okay, so now we will try to follow this condition third. So actually this plane is again inclined 45 degree with the vertical plane. So we will reconstruct this same surface here at an angle of 45 degrees. So actually we will draw one line which is inclined 45 degree with the vertical plane, means it is making 45 degree with xy line below the xy line. So this line is actually the center line of this surface. Okay, so this surface is inclined 45 degree. Okay, so previously it was like this, and it is inclined with the vertical plane, means xy line. So this will be inclined like this. Okay, so now we will reconstruct this surface here, which is inclined 45 degree with the xy line. Now we will draw vertical projections from 1 1 2 1 3 1 4 1 5 1 6 1 7 1 8 1, and horizontal projections from 1 dash 2 dash 3 dash 4 dash 5 dash 6 dash 7 dash 8 dash. Okay, so when we have drawn vertical projection from 1 1 and the horizontal projection from 1 dash, so we will get this point, and this will be point 1 1 dash. Vertical line from point 2 1, horizontal line from 2 dash, so this point will be actually 2 1 dash. Similarly, horizontal line from point 3 dash, vertical line from point 3 1, so we will get this point 3 1 dash. Horizontal line from point 4 dash, vertical line from point 4, so we will get this point 4 1 dash. Clear? Now vertical line from point 5 1, horizontal line from point 5 dash, so we will get this point 5 1 dash. Similarly, horizontal line from point 6 dash, vertical line from point 6 1, so we will get this point 6 1 dash. Again, vertical line from 7 dash, horizontal line from point 7 dash, so we will get this point 7 1 dash. Finally, we will draw vertical line from point 8 1, horizontal line from point 8 dash, so we will get this point 8 1 dash. Okay, so now we are having 8 points, and we will connect all these points, then we will get this surface which is projected in the front view, and this surface is inclined 30 degree with the horizontal plane, means with the ground, like this, and again it is inclined 45 degree with the vertical plane. So you can see this figure like this. So this will be the final figure. Okay, so this is this one. Okay, so now we will talk about the projection of solids in the next video. Thanks for watching this video. All the best.